This video will show you how to solve logarithm equations. Now take a look at this equation right here. This is the simplest form you will see that's a log equation, and this is considered a log equation because it's got the word log written. Now in this case, the word log is written just once on one side. And if that's the case, all we have to do is convert our logarithm expression into an exponential expression. And we take that base of 5 raised to the third power. So this is 5 to the third power equals x. And all we have to do is use our calculator to do 5 to the third. 5 to the third is 125. Now up here it also tells you, remember, you need to check your solutions because you cannot take the log of 0 or a negative number. So we're fine if we put 125 right here and we do the log base 5 of 125. It does equal 3 because 5 to the third equals 125. But you will find some of these later on in the video that you're going to have to throw a solution out. Very similar to the last one, it's just I have a binomial expression right here, but it's still the situation where logarithm is written one time on one side. So convert to your exponential. 5 raised to the second power equals this expression right here, which is x minus 2. And what we have is a simple linear equation. 5 squared is 25 equals x minus 2. Add 2 to both sides, so we get x equals 27. And we can check this one in our heads pretty easily. 27 minus 2 is 25. And this is asking me what is the log base 5 of 25? It's 2, so that one checks. Similar problem. Now you might notice this negative over here and think that we're in a no solution situation, but it is okay for this number right here to be negative. What is not okay is for us to try to take the logarithm of a negative. So we can still set this up. This is 2 to the negative 2 equals x minus 1. Remember, a negative exponent creates a fraction. 2 to the negative 2 is 1 over 2 squared, still equal to x minus 1. This is just 1/4 equals x minus 1. Solve this by adding 1 to both sides. And you can express your answer multiple ways. You can write it as the mixed number 1 and 1/4. You can write it as the decimal 1.25. It doesn't matter. Whatever you do, you can plug it back in here and check. It might be easier for us to check in the fraction format. So put this in here because if I put 1 and 1/4 right here, 1 and 1/4 minus 1 is just 1/4. So what you're looking at is log base 2 of 1/4. Does that equal negative 2? And the answer is yes, because 2 to the negative 2 equals 1/4. So all of these last ones have been fairly simple because the log word is written just one time on one side. This is still simple. A couple of ways to look at this. One is to remember what ln is. ln just stands for log base e of x equals 3. We still have the log word written one time. We can go to our exponential and get e to the third equals x. And this is just a calculator situation now. You just use your calculator to do e to the third. The way that I deal with this, rather than writing out log base e, which really does show you why it's e to the third, is I just put a little e underneath each one. So I'm doing the same thing to both sides. So I'm raising this as e to the ln of x. Remember, e to the ln of x, the e and the ln cancel out and we just get x. And then all we have over here is e to the third power, which I did over here, which we said was about 20.09. So that's the way I get rid of ln. I just do e to the on both sides, and my ln will cancel out. Exact same kind of problem here. I'm just going to put a little e as the base for both of those. E to the ln cancels, we get x. All I have to do is evaluate on my calculator, e to the fourth power. And it depends on your calculator. On the graphing calculator, e is located at second ln, and e to the, and you type in the 4, comes out about 54.6. And this is very easy to check because you can now go back to your calculator and just type in ln 54.6, and it's not going to say exactly 4 because we've rounded this off, but it will be very close. Now, different situation here. Notice log is written more than once. So we need to use those properties from a couple sections ago to consolidate or condense this side. We need to write it as a single log whose coefficient is 1. So property of log of something plus log of something condenses into log of their product. It's the same base, and all I did was write this as the product. Then I'm going to clean that up Just distribute the x through there. This is log base 2 of x squared minus 7x equals 3. Finally, I have a single logarithm over here. Now it's time to convert to exponential form, which will be 2 to the third equals this expression right here. Take care of your 2 to the third, which is 8. And now this is a plain old quadratic equation. Subtract 8 from both sides, which gives us x squared minus 7x minus 8 equals 0. Factor as x minus 8 times x plus 1. And if you solve each of these, we get x equals 8 or x equals negative 1. This is where it becomes important for us to start checking. So here's the check written out. All I did on this first one right here was put 8 in for those x's. So log base 2 of 8 is 3, because 2 to the third gives me 8. Doing this right here, 8 minus 7 is just 1. Log base 2 of 1 is 0, because 2 to the 0th gives me 1, and that checks. So we're definitely going to keep the 8. On this one, I've put negative 1 in for both of these x's, and this is the expression. As soon as I get right here, log base 2 of negative 1, I can quit. I don't even have to look right here, because this is saying take the log of a negative, which we know is impossible. So that says the negative 1 gets thrown out. So our only solution is x equals 8. Very similar problem. The log is written twice. Now notice there is no base written here. It's understood to be base 10, and I'll use that base 10 when I get things condensed. So let's just finish out the property. Log of something plus log of something because log of their product. Then I will distribute the x through there. Now this is where I might want to think about or pencil in a little 10 right there, because I want to change this to exponential form. So this is 10 to the first equals this expression right there. I have seen people over the years just drop off the log and they're left with x squared minus 3x equals 1, and you can't do that. That logarithm word means something, and what it means is you need to convert to exponential form. Then this finishes out like the last one. Let's pull the 10 over, factor it, and solve. Solve that, we'll get 5. Solve this, we'll get negative 2. So let's check. Here's my check written out for the 5. Now because this is plain old log, which is base 10, but it's located on your calculator. So you can use your calculator to check this. Log of 5 is approximately 0.690. Log of 2, which is what that is 0.3010. Add that up as 1. That one checks. But same problem as last time. If you put negative 2 in here for this x right there, then you're taking the logarithm of a negative, which is not possible. Therefore, negative 2 gets thrown out. Now we have ln, but it's the same idea. It's a different property right now. It's a minus in there. Remember, log or ln of something minus log or ln of something becomes a division problem. So my single log over here is ln of that over the 4x plus 3. Now, because ln is written on both sides, I can drop that off. And the mathematics of dropping it off is what I just showed you a second ago. I can think of this e to the, so that goes away, and all you're looking at is that right there, which is a basic proportion that I got rid of the parentheses. To solve this proportion, I'm just going to cross multiply. So if I do this, x times x plus 2 has got to be distributed, and then of course 4x plus 3 times 1 is just 4x plus 3. So that's what our next thing says. It's a quadratic because it's got an x squared in it. The best way to solve this is to subtract 4x and 3 over from both sides, and then factor this. It factors as x minus 3 times x plus 1. Solve each of these and we get 3 and negative 1. But let's check. This is just more stuff to write out. This is putting 3 in here. Now I did this a little differently. Right here you could just use your calculator. Type in ln of 5 minus ln of 15. See what that number is on the calculator. Then do ln of 1/3. Be sure the 1/3 is in parentheses. And those two numbers will match. But another way to check without using your calculator is what I did here. 3 plus 2 is 5. Do this arithmetic gives me 15. ln of 5 minus ln of 15 can be rewritten as ln of 5 over 15. And 5 over 15 reduces to 1/3. So that's another way to check. I really think the best way to check is just type it in the calculator because that button is available. We're still having a little problem down here. If I put negative 1 in here, now right here we're okay. Negative 1 plus 2 would be 1. But this arithmetic, 4 times negative 1 is negative 4, plus 3 is negative 1. I would be taking the natural log of a negative, which I'm not allowed to do. So this negative is going to get thrown out. All right, this one's a little more complicated, but first off, the word log is only written one time on this side. But I've got to do something with this too, because if you recall a couple of screens ago, it said you have to have a single log with a coefficient of 1. Well, this coefficient goes back and becomes a power. So that's what's going to happen on this side. Here, log base 3 of 9, I can do that arithmetic. Log base 3 of 9 is just 2 because 3 to the second power gives me 9. So this is what it looks like on the second line. I have brought that coefficient back to be a power. Log base 3 of 9 is 2. So put that together. It's going to give us 4. I have a single log. It has a coefficient of 1. Now it's time to go to the exponential. 3 to the fourth gives me this expression. Do your arithmetic over here is 81. Now you have a couple choices right here. I could FOIL this out and solve it that way, but I think the easier way to go right here is to realize this is something squared, and to undo something squared, all we have to do is take the square root of both sides. So the square root of this over here gives me x plus 4. But remember, when you solve an equation like this by taking the square root, you're going to get a plus or minus. So this next screen says the same thing, but a little more neatly. Now I have to separate this out into the two cases. I have to write out my x plus 4 equals positive 9 and write out x plus 4 equals negative 9 and solve. Subtract 4 from both sides gives me x equals 5. Subtract 4 from both sides gives me x equals negative 13. As far as checking goes, this one, if I put 5 right here, 5 plus 4 is 9. Log base 3 of 9 is 2. 2 times 2 is 4, which is what we have on this side. But if I do my negative 13 right there, I got a problem, because negative 13 plus 4 is negative 9. That would be taking the log of a negative number. Therefore, that gets thrown out, and this is the only solution that we keep.